What about if one of the limits is infinite? You might say, well, does it even make any sense? Well, let's look at it. So let's say that we have a function that is continuous all the way from a and up. Okay, so something looks like this. And what I may want to do is compute the area under that curve from 1 all the way to infinity. Now you might wonder, why would you want to do that? Once again, isn't that an infinite region, so shouldn't it have an infinite area? Well, it turns out that it doesn't always. Sometimes it does, sometimes it doesn't. But theoretically, conceptually, we can still make sense of this concept. So what we're after, we're going to define the integral from a to infinity of f of x dx. Notice once again, this is an improper integral in the sense that the upper limit is not a number. Okay, we're dealing with something that really shouldn't make any sense, but we're going to give it meaning by using the limit process, just exactly like we did before. So we're going to pick a value k, which is not at infinity, but it's a finite value. And then we're going to construct the integral from a to k of f of x dx. No problem there. Everything is fine and dandy. Both limits are finite. The function is continuous, and so we don't have any problems. Okay? And then what we're going to do is we're going to let our limit, or this upper artificial limit k, go all the way to infinity. Bye-bye. We'll see you later. And we'll take the limit as k goes to infinity in order to figure what that is. As before, if the limit exists, then we say that the integral is convergent. And if the integral, the limit does not exist, then we say that the integral is divergent. I showed you what happens when we are going from a number to positive infinity. Of course, we can do exactly the same thing if we're going the other way. So if we consider the integral from negative infinity to a of some function, well, that's going to be equal to the limit as k goes to negative infinity of the integral from k to a of our function. And you may wonder, nice exercise, good intellectual thing, great source of exercises and test questions, but what is it good for? So, having given a technical definition to these improper integrals, the question is, what do they mean? Okay, why are we computing them? Well, we've seen already that when there are no asymptotes involved, like in the case of sine x over x, what we're actually doing is we're computing the area of a region that should make sense, that should exist. I mean, our intuition or our sight, our eyes tell us, well, there should be an area there. Okay, so it's just that technically we were stuck because of the discontinuity. Well, we're getting around the discontinuity by using the limit process. But what about the situation where asymptotes are involved? And we've seen that we could have a vertical asymptote, or we could have a horizontal asymptote being a boundary of the region whose integral we're computing. Well, in this situation, what we're actually doing is we're providing some qualitative information about the situation. Now, mathematicians love to go through all of the technicalities about computing which integrals or which improper integrals converge, which ones diverge, and how that relates to other stuff that we're going to do later about infinite series and so on. And yes, there is all that kind of applications, but that's going to come later. For now, what you want to think about to have a little bit of a motivation is to realize that there are some applications where we want to find some kind of qualitative information. Let me give you just one example. Okay, and example is the following. We saw in the class on work that it's possible to use integrals to figure out how much work is needed to lift a satellite or rocket up to a certain height. Well, can we push that satellite all the way to infinity? Okay, can we go anywhere, or do we need an infinite amount of fuel? It turns out that the work to lift an object to an infinite height is finite. What does that mean? It means that if I start from Earth and at Cape Canaveral I take my rocket and I decide to shoot it all the way to infinity and beyond, well, all I need is a finite amount of fuel. And you might say that's kind of silly anyway, because that's only assuming that the Earth is the only object in the universe, in which case why would we want to go to the edge of the universe if there is nothing there? On the other hand, if there are other objects, then their gravity will come into effect and all kinds of complications. Fine, I understand that. But on the other hand, again, this is one of the main applications of these infinite integrals. You're going to see some more. You're going to see some which hopefully are going to make more sense to you. Okay, but this is just to give you a little bit of a motivation.